What's up, y'all? Welcome back to the channel. So today I'm going to be showing you how you can make this really cool animation in Blender where we sort of make a path walk along the surface of an object. I've had a lot of fun using this and making sort of like ivy and vine growth simulations. And we're going to do this using the simulation nodes, which are coming in Blender 3.5. If you want to get the 3.5 alpha branch that already includes these, there'll be a link in the description below where you can download that. Also, if you want to get the project file for this tutorial, along with another file that's sort of like a more optimized version designed specifically for growing ivy and vines, there's a link in the description to my Gumroad where you can get both of those files together for $1. So, with that out of the way, let's hop into a new scene here, and I'm going to start out by adding in a Suzanne head, and I'm going to give this 2 levels of subdivision, apply that, right-click, shade smooth. Then I'm going to go ahead and add in a plane and just lower this down on the z-axis. And then with that all done, I'm going to save my file because, again, just like I mentioned in my other videos, this is a Blender alpha branch, so it is very unstable. Now with that done, I'm going to click on my cube, jump over into geometry nodes, and let's just add a new geometry node modifier. Slide this over, and I'm going to drag in my plane from up here as an object. And before we even add in the simulation nodes, I'm just going to plug this in here, then add in a distribute points on faces node, and a points to vertices node, and a points to vertices node. And if we switch this to relative, you'll see the points actually spawn where the plane is in our scene. And now we can add in our simulation nodes. Be sure to add in the output node first. I don't know why, but at least on the branch that I'm using, you have to do that, otherwise Blender gets really mad and crashes on you. To start out, I'm going to add in an extrude mesh node. And if you saw my last video, we're just going to be using a lot of the logic we used in that one here. So if you want a slightly better explanation of everything that I'm doing, go ahead and check out my previous video on particle trails in simulation nodes. But for here, we're just going to go ahead and add in a store named attribute node, set this to Boolean, plug this top value into here, name it top, then we'll slide back to before our extrude mesh, Shift A, grab an attribute node, set this to Boolean as well, name it to the same thing, then grab a vertex neighbors node, a compare node, set this to integer, and a Boolean math node. Plug this attribute into the top, then plug this vertex count into the top slot of our compare node, set this to equal, and plug this result into here. Basically all we're doing here is limiting the extrusion to the last extruded point or to a newly created point. And we can determine if it is a newly created point using this vertex neighbors node, because if the vertex count equals 0, then that means that the vertex isn't actually connected to any other vertices, so it has to be a new one. And we'll have to switch this to OR on our Boolean math node. Then we can just plug this into the selection slot, switch this to vertices on our extrude mesh, that's important. And now we can actually work on some new stuff. So I'm going to grab my Suzanne, drag this over here as well, and I'll switch this to relative, grab a capture attribute node, set this to vector, and I'm going to capture the position of all my points here, trying to keep my nodes more organized nowadays. Then let's grab a geometry proximity node. We'll also grab a sample nearest surface node, and we're going to plug the position attribute we capture here into the source position and the sample position on our respective nodes. Set this from float here to vector. And we're going to capture the normal value of the nearest face. Just plug your geometry from whatever you want it to interact with into the target geometry and the mesh geometry here. And now we're going to do a little bit of vector math. So I'm going to do my best to explain this, but if you have some trouble, I recommend just Googling the right-hand rule. That'll explain what I'm doing here. But basically, we're going to do an operation called a cross product. You can see that here. And so if we plug the normal value from our sampled nearest surface into here, the cross product is going to give us a vector that is at a 90-degree angle to both of the vectors we put in here. So I'll try doing some annotation. So basically what the cross product does is it will give us a vector, it'll output a vector here, that is at a 90-degree angle to both the vectors that we put into here. So what we can do is say we have a normal vector pointing like this. No matter what vector we add in, it's just going to basically be rotated around this point at the base. So no matter what we put in, it's always going to be operating essentially tangentially, because the only vectors and every vector that is at a 90-degree angle to this vector is going to lie in the plane of the surface of our mesh. Hopefully that explains it. Again, it's a bit difficult to explain this via the annotation tool and a short Blender tutorial, so if you're having an issue with it, I highly recommend just Googling either the cross product itself or just Googling the right-hand rule will explain it pretty well. So we can just add in some random noise. I'll grab my noise texture, another vector math node, plug this into here, and we're going to have to subtract 0.5, so that way our noise texture goes from negative 0.5 to positive 0.5 instead of just 0 to 1. Then I'm going to switch this to 4D and grab a mesh island node. Now if we plug this island index into the W, then that means that each spline that we get when we sort of start extruding is going to follow its own random noise field, if you can think about it that way. So if I plug this into here, then plug this into the offset, and then come down here to the bottom right-hand corner, you'll get a little plus sign and you can drag up a new window, add myself a timeline, and if I hit play, you'll see they all go pretty random and squiggly, and that is just because my noise texture is way too large in terms of scale. I'll lower the detail as well so we get some smoother motion. And now you can see that while it is random, it's sort of all just hovering around Suzanne, and that's because, again, it's pretty far away, and so they're all just trying to stay at a constant distance from each face. So if I was to, say, distribute my points on the Suzanne head by plugging this in here, you'll see they're still following the surface. We can also lower our offset scale a lot. You'll see this a bit clearer. But now you can see they're all just sort of stuck to the surface, and so that's exactly what we want. Now I'm going to plug my points back in here, and I'm going to come back up to my geometry proximity node here. Now I can grab a mix node, set this to vector, and then if I grab a map range node, I can use this distance between every point and the surface of Suzanne to basically determine if the line should be flying towards Suzanne or sort of crawling and walking along the surface like we see here. So I'll plug this result value into the factor, and if I adjust these from min and max and to min and to max values, then I can basically say, okay, At what distance do I want it to start switching from flying towards Suzanne to just walking along the surface? And in order to do this, we're actually going to need to tell each point how it should be flying toward the surface, and easy solution there. Just plug this position here into the top of a vector math node, and this captured position from up here into the bottom. Set this to subtract, and now this vector will point from each point toward the surface of Suzanne. And there we go. Now you can see we're sort of getting like this growing towards effect. And like I was mentioning earlier, if I adjust this from max value, you'll see they start obeying the sort of follow surface vector a lot sooner. Another thing that's useful is this from min. This sort of gives you like a buffer of at what point should it just start only obeying the follow surface rule, even if it's not immediately touching the surface. And so if you give a little bit more space, then that means that you're less likely to have clipping issues. And so that's one thing to consider when you are making your final project. You can also add in a normalize node here, so that way this vector isn't affected by the proximity of the point to the mesh, and a scale node if you like. And that's basically the entire walking along the surface part of the effect. I am going to add one more thing though, and that is I want to make it so that these will occasionally like branch and split off. And to do that, I'm going to add in a mesh to curve node and a curve to mesh. Then I'm going to grab a duplicate elements node. Set this to spline and grab a join geometry, plug that in there, and join it with our original curve. Now it's actually important to make sure that the original curve is plugged in above the duplicated elements curve on this join geometry. I don't know why I get little glitches if it's done otherwise. If anyone knows why that might be, please tell me because I cannot figure it out. Now I'm going to add in a junction there. Shift A and grab a store named attribute node. Set this to integer and spline. And I'm going to name this to spline age. Now if I grab an attribute node, set this to integer as well, name it to the same thing, then grab a scene time node and a switch node, set this to integer, and now what I'm going to do is I'm going to plug this exists Boolean value into the switch, and essentially I'm just going to tell Blender, okay, if the attribute exists, just make it stay the same. So I'll plug this into true, and then if not, I'm going to plug the frame value into the false. So that way only new splines are going to be assigned an age value, otherwise it will stay the same as their initial spawning frame. Then just plug this into the value slot and slide this over. Then I'm going to duplicate this spline age attribute node. Shift A, grab a math node and a scene time node. Now I'm just going to add the essentially spawn frame attribute to the current frame value. Then I'm going to duplicate this and I'm going to set this to modulo. So what the modulo operation does is essentially whatever this bottom value is, it's sort of like the cap, the largest value it can be, before it snaps back to 0. So if I set this to 5, then the value, then once it hits 5, it'll just sort of loop back to 0 and it'll loop around forever. And that is very helpful for us. And if I grab a group input node, I can plug this in here. And this is going to tell us essentially how many frames have to go by, no matter what, for a branching to possibly occur. So right now, if I grab a compare node, set this to integer, and set this to equal, and set this to equal, say 1, then plug this into the selection. I'll restart my sim, and you'll see we start branching no matter what after a certain age. And one thing we can also do to prevent them from staying so clustered together is to just come back to our noise texture, add in a math node, set this to multiply, and just multiply it by 10, so that way there's a larger difference in the noise texture between each individual spline. I'll reset this, and now they grow just a little bit faster. You could also use this as sort of like a Spider-Man web slinging effect. I just immediately realized that right now. So that is an idea you could play around with. But now I don't want every single one of these splines to duplicate every 5 frames. So what I'm going to do is first I'm going to set this to something like 12. So that way that'll lower our duplication rate a little bit on its own. Then I'm going to grab a Boolean math node, set this to and I'm just going to grab a random value node. Set this to Boolean, then grab a scene time node, plug the frame value into the seed, and plug this value into the Boolean value on there. From my group input, I'm going to plug a slot into the probability. Now if I lower this to something like, I don't know, 17, 18%, you'll see there's a lot less branching going on. And yeah, that's pretty much the entire effect. The rest of it is just going to be making it look pretty. And so I'll show you how to do that real quick. You're going to want to make sure to add in a merge by distance as the very last node, just to save yourself some computation time. But if we come in here and add in a curve to mesh, and a mesh to curve before it, just like we did before inside our simulation nodes, then grab our good friend set curve radius and the spline parameter node and a good old float curve. We can plug the factor value from here into the value slot on our float curve, then plug this into our set curve radius node, grab a curve circle, plug this into the profile curve, and you're going to want to lower the resolution on this to something a lot lower, like 6, and then add in just a simple math node set to divide to lower the actual radius of your sort of like vines or ivy, whatever you like them to be. Reverse this float curve so that it's thicker at the bottom and thinner at the end. Then toss in a merge by distance node right here at the end. You'll want to set this distance to something very, 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 very small. I'm going to go with 0.00001 meters. And that will just get rid of like any perfectly overlapping vertices. Might be able to go 1 order of magnitude larger. As you can see up here, that's lowering our resolution a lot, which is nice. You do want to be really, really careful with this because it grows essentially exponentially. And so it's very, very easy to add in a lot of geometry. So that's just something to be cognizant of. It's also sometimes better to control this density value and have like fewer spawn points and just more branching. Sometimes that looks good. I like to just have like 3 or 4 spawn points and then raise up my probability a good amount. You can also lower this value here as well, of course, because this just sort of shows off the branching a lot nicer. That is, of course, just me though. And again, if you guys want to get a different version of this, specifically designed for growing like ivy and vines onto objects, there is that link in the description to my Gumroad if you would like to check that out. It is a lot more geometry efficient. It just involved a lot more, much more complex geometry nodes that I didn't really want to try to stuff into this video. So yeah, that is pretty much the entire thing. Again, if you guys like this, consider liking, subscribing, all that YouTube jazz, and hopefully I will see you in the next video.